Hello everyone, I welcome you all to Scientifuse. In today's class, we will be discussing the most important chapter of our class 12 chemistry, the haloalkanes and haloarenes. Before we jump into the depth of the chapter, I would like to introduce you to some basic concepts in haloalkanes and haloarenes. Basic concept includes what are the types of haloalkanes, the preparations, the chemical properties, and then so on and so forth. We are going to move ahead with mechanisms. Then we will deal with haloarenes. Then we will deal with some named reactions and so on and so forth. So please stay focused and listen very, very carefully. Now, whenever we hear about the word haloalkanes and haloarenes, the very first thing that we should know is what are haloalkanes and haloarenes. So I say halo means halogen. Alkanes means whenever there is carbon, single bond, carbon. Again, coming to this, I say halo means halogen and arenes means ring-like structures. So I say whenever a hydrogen atom in an alkane is replaced by a halogen atom, we term it to be haloalkanes. Similarly, whenever I say that a hydrogen atom is replaced by a halogen atom in ring-like structures, it is called as haloarenes. I'll just explain you with simple examples. For example, I say this is an alkane. Got it? How do we identify whether a particular compound is alkane, alkene or alkyne? Whenever there is carbon, single bond carbon, I say it is alkane. Whenever there is carbon double bond carbon, I say it is alkene. And whenever there is carbon triple bond carbon, I say it is alkyne. Correct? So we say that here this is completely an alkane. This is an alkane. But if I want to replace this hydrogen atom with a halogen atom, then in that case, this will be termed as haloalkane because this chlorine is a halogen. To say halo means halogens, and halogens include the group 17 of our periodic table, which is fluorine, chlorine, bromine and iodine. So whenever any hydrogen atom is replaced by chlorine, fluorine, bromine or iodine, we say a particular compound is said to be a halo compound. Now whether it is a haloalkane or whether it is a haloarene, it depends. If the hydrogen atom of an alkane is replaced by a halogen atom, then I say it is a haloalkane. And if a hydrogen atom of a ring-like structure, that is arene, is replaced by a halogen atom, for example, this, if it is replaced by fluorine, chlorine, bromine or iodine, I say it is a haloarene. Is it clear? Now moving on to the next, I discuss the classification of haloalkanes. Classification of haloalkanes. This is very important, so pay attention. Whenever I talk about classification, I say the classification of haloalkanes is done on two bases. First, on the number of halogen atoms. On the number of halogen atoms. You can add here on the basis of number of halogen atom, and on the other part, I say I can also classify haloalkanes on the basis of hybridization. Now let us have a look. On the basis of number of halogen atoms, I say that a particular compound can either have one halogen atom, it can have two halogen atom, or it can have three halogen atom. So on the basis of that, I say it can be classified into three categories: monohaloalkane, dihaloalkane, trihaloalkane. Very simple. I say monohaloalkane by the word mono. Mono means one. Then I say halo means two. I mean to say this, that mono here means one and halo here means halogen. Di means two, halo means halogen. Tri means tree and halo means halogen. Got it? That means whenever there is presence of one halogen atom, it will be called as monohaloalkane. When there is presence of two halogen atom, it is called as dihaloalkane. When there is presence of three halogen atom, it is called as trihaloalkane. Examples are listed below. Here, one halogen atom, so monohaloalkane, two halogen atoms, so dihaloalkanes, three halogen atoms, it means trihaloalkane. Now, this dihaloalkane can further be classified into two categories. I say dihaloalkane can further be classified into two categories. What are those two categories? Those are the geminal dihalides or gem dihalide. Got it? Or the other I say is a vicinal dihalide or vis dihalide. Okay, very simple. The terms should be very clear to you first. Geminal dihalides means basically two halogen. Okay, two halogens. I say when the two halogen atoms are attached to the same carbon atom. It is called geminal dihalide. For example, let us say this. Can you see? The two halogen atoms are attached to the same carbon atom. Got it? This is the carbon atom and these are the two halogen atoms. So whenever two halogen atoms are attached to the same carbon atom, we say that it is geminal dihalide. And what do we mean by the word vicinal dihalides? I say when the two halogen atoms are attached to different carbon atom. Are attached to different carbon atom. For example, I say one is attached here and the other is attached here. Can you see? It means that both of these halogens are attached to two different carbon atoms. Is it clear? Now you see, next category that we have is on the basis of hybridization. On the basis of hybridization, I say it will be classified into two categories. CsP3x and CsP2x. You need to understand what does this mean. CsP3x means carbon is sp3 hybridized and then this halogen is attached to the sp3 hybridized carbon. Okay. Again, here I say carbon is sp2 and this halogen is going to get attached to the sp2 hybridized carbon. Now, what is this sp2, sp3? You should know that. Whenever there is triple bond, we say it is sp hybridized. Whenever there is double bond, I say it is sp2 hybridized. And whenever there is single bond, I say it is sp3 hybridized. Is it clear? Now, under this category, I study three basic halides. What are those three basic halides? First is the alkyl halides. Then we have here allylic halides. And then we have here the benzylic halides. One thing you should know, whether it is an alkyl halide, whether it is an allylic halide, or whether it is a benzylic halide, in all these three, one thing will be common, that is halogen will be attached to sp3 hybridized carbon. Got it? So I say in sp3 hybrid, in CsP3X type of hybridization, that means I say the carbon is sp3 hybridized. I have three categories: alkyl halides, allylic halides, and benzylic halides. Under this category, I have two types of halides. What are the two types of halides? Vinylic halides and vinylic halides, and I say aryl halides. Now we are going to discuss these in details. Moving on to the first category, I say CsP3X. Under this, I'm going to take three halides. What are those? First I talk about is alkyl halide. Next, allyl halide. And then benzylic halides. Listen very carefully because these are important in your exams. You get questions to name the particular compound and then identify whether it is an alkyl halide, whether it is allyl halide, benzylic halide, vinylic halides, aryl halides, or whether it is a gem halide or vicinal halide. So it should be very, very clear to you. Okay. When I talk about the word alkyl halide, alkyl means alkyl group and it is represented as R. On the basis of this, I say we have three types. One is the primary alkyl halide. Let me write here primary alkyl halide. The other is secondary alkyl halide. And the third is the tertiary alkyl halide. Okay. This primary is represented as 1 degree, secondary as 2 degree, and tertiary as 3 degree. Am I clear? Okay. Now see, in case of primary, I say there will be 1 R group. In case of secondary, 2 R groups, and in case of tertiary, 3 R groups. And what are these R's? These are, as I told you, are alkyl groups. Now, these alkyls can be methyl, ethyl, propyl, anything. In this, I say when there is presence of 1 R group. Okay, let me draw the structure here so that I can explain you well. I say primary, secondary, and tertiary. In primary, I say there will be presence of 1 R group. In secondary, I say there will be presence of 2 R group. Okay. And in tertiary, there will be presence of 3 R group. This is the simplest thing that you should know. In case of primary, 1 R group, and see, this is a halogen, halogen, halogen. So it is a halo compound. Got it? Alkyl halide means halogen. Having how many R groups will decide whether it is primary, secondary, or tertiary. So what do I say? 1 R group, 2 R groups, and 3 R groups. Is it clear? Moving on to the next, that is the allyl halide. Or you can say the allylic halides. Allyl halides or the allylic halides. Let me explain it with the help of an example. Suppose I have a compound like this. What can you observe? Looking at this, what can you see? First thing I see is a double bond. Okay. Second thing I see that this halogen atom is attached to a carbon here. This has to be CH2, okay? Here, this has to be CH2, yes. Okay. This is a double bond. What else do you see? We see a halogen also. Now, can you see? Listen to me very carefully. Did you see that this halogen atom is not directly attached to carbon double bond carbon? Isn't it? See, this is not directly attached to carbon double bond carbon. Instead, it is attached to a carbon which is next to carbon double bond carbon. So, allylic halides are those haloalkanes in which the halogen atom is attached to a carbon atom which is adjacent to carbon double bond carbon. And the most important thing is, can you see? There is a single bond. Single bond means it is an sp3 hybridized carbon. So how do I construct my sentence? I say compounds in which halogen is attached to carbon that is adjacent to carbon double bond carbon, and the carbon to which halogen is attached is sp3 hybridized carbon. Got it? That is why this allylic halide falls under this category, CsP3x. That is, halogen atom is attached to a carbon which is sp3 hybridized. Moving on to the next, we have here the benzylic halides. Benzylic halides. By the word benzylic, it is little bit clear to us that it has something to do with the benzene ring. Look at this now. Suppose I have a benzene ring and a halogen atom is attached. Can you see? Again, the same thing here. This is a carbon double bond carbon. I say carbon double bond carbon. This carbon is sp3 hybridized, and this is a halogen which is attached to an sp3 hybridized carbon atom next to an aromatic ring. In short, I can say that this is an aromatic ring, or I can simply say that it is a benzene ring. So how do I construct my sentence? Compounds in which halogen is attached to an sp3 hybridized carbon atom or carbon next to a benzene ring. Simply that. Got it? So this again falls under which category? CsP3x. Moving on to the next category, I say CsP2x. In this CsP2x, we have two broad categories. One is the vinylic halides and the other is the aryl halides. Now see, in vinylic halides, this is falling. See, that is why I am telling you this is important. This falls under CsP2x. What do we mean by the word CsP2x? It means carbon is sp2 hybridized. If carbon is sp2 hybridized, it means what type of bond is going to exist between two carbon atoms? Carbon double bond carbon. And then that halogen is directly attached to carbon double bond carbon. So in vinylic halides, I say, let me take this example, CH2 and X. Can you see this? Here you see that there is carbon double bond carbon, carbon double bond carbon. And what is this? This is a halogen atom. So halogen atom is directly attached to carbon double bond carbon. So this is known as vinylic halide. So what do I say? Compounds in which halogen atom is attached directly, we'll add the word directly, to carbon double bond carbon. That is to sp2 hybridized carbon. Clear? Okay. Let's move to this aryl halides now. Aryl halides also, it is a very simple concept. In aryl halides, I say this carbon here. Now see this carbon here, no, is what? sp2 hybridized, and this halogen atom is attached to an sp2 hybridized carbon of an aromatic ring. So all those compounds in which the hydrogen atom is attached to an sp2 hybridized carbon atom of an aromatic ring, it is called as aryl halides. So I'll say compounds in which halogen atom is attached to sp2 hybridized carbon atom of an aromatic ring. Clear? So this is all that we have for classification. Now, moving on to the next, I say we will be studying the preparation of haloalkanes. So I say, what are the general methods of preparation of haloalkanes? Okay. Talking about the general methods of preparation of haloalkanes, that means I want to tell you how haloalkanes are being prepared. So, the first method by which haloalkanes are prepared are from alcohols. That means here the task will be to convert alcohol into haloalkane. Pay attention, this is a very important concept. Now see, suppose, look at this carefully. From alcohols, it can be prepared by various methods. For example, if I take alcohol and if I react it with this entire thing, no, is called as Lucas reagent. Then what is going to happen? There will be a formation of a haloalkane, because the target ultimately is from alcohols, you have to convert it to haloalkanes. And this process is known as Groove's process. Got it? Next process that you are going to have is this NABR. When you react alcohol with NABR and H2SO4, I say you are refluxing this. So what are you going to get? RBr plus H2O. Then again, the third thing that we have here is, what is this? This is actually phosphorus trihalide. When you react an alcohol with phosphorus trihalide, I get 3RX plus H3PO3. Correct? Then the next method is with PCl5, which says RCl plus POCl3 plus HCl. And one more method that we have is reaction of alcohol in the presence of pyridine and SOCl2. What is this SOCl2? This SOCl2 is known as thionyl chloride. All right. So what do you get here? RCl plus SO2, which is in the form of gas, plus HCl, which is also in the form of gas. And remember one thing, this here is pure. Got it? So let us see what are all these. Look at this. I say general methods of preparation of haloalkanes, correct? From alcohols, how do I prepare it? From alcohols, I'm going to prepare it in various ways. What are the various ways that I can use to prepare? First of all, I can say that whenever I react this alcohol with a Lucas reagent. What is this Lucas reagent? Lucas reagent is HCl plus ZnCl2. Very, very important. These things should be there always in your mind. What is Lucas reagent? HCl plus ZnCl2. Whenever we want to react this ROH with HCl and ZnCl2, we are going to get a haloalkane and water will be released out. Correct? And this process is known as Grove's process. Second, we have alcohol on reaction with sodium bromide and sulfuric acid. It is going to give you RBr plus H2O. Then you have alcohol when it reacts with phosphorus trihalide. It is going to give me 3 moles of Rx and H3PO3. Then you have PCl5, phosphorus pentachloride. It is going to give RCl plus POCl3 plus HCl. And then you have pyridine with SOCl2, which gives you RCl plus SO2 plus HCl. Is it clear? Now, the most important thing here is, did you see that the first thing that we studied was ROH on reaction with HCl plus ZnCl2. What did we say? This was basically Lucas reagent. Got it? Is going to give you what? RCl plus H2O. This was known as Grove's process. Now, did it strike your mind that why are we taking this ZnCl2? Because this ZnCl2 is going to weaken the carbon and hydroxide bond. So if this bond easily breaks, then what is going to happen? We can allow the reaction to take place easily. Now tell me one thing. If this bond breaks, you are going to get a carbocation. Got it? And this carbocation will be an intermediate and it is going to show good reaction. Is it clear? Now see, I say ROH when it reacts with HCl and ZnCl2, it is going to give me this. How will I get this? See, ROH on reaction with HCl, maybe in the presence of this ZnCl2 is a catalyst. Okay. So what will happen? This chlorine is going to come here and water from here is going to go out. So what will I get? I get chlorine getting attached to an alkyl group and water is being released. Got it? And this ZnCl2 is going to act as a catalyst. And what will the role of this catalyst be? To break this COH bond so that a carbocation will be formed. Because as soon as this OH and this R here obviously will have carbon. Of course, alkyls groups will have carbon. So when the bond breaks, this is going to be positively charged. That means it is going to be called as carbocation, and this Cl minus is going to go and attach to it and form RCl. And what is this? This is a haloalkane. Is the first process clear? This is from alcohol. Moving on to the next, I have this ROH in the presence of NaBr plus H2SO4 is going to give you what? RBr plus H2O. Okay, that means this is something like this. And then you have H2SO4. So what is going to happen? What is going to happen here? This, and then of course this H2SO4 also will have to make use of this. So let us have a look at this reaction properly, okay? I'll show you step-by-step mechanism. See this now. Here you see ROH. Is it clear? Then you have NaBr, and let us say you're adding sulfuric acid to it as well. Okay. What are the products that you can get? First of all, you should know as soon as this happens, if this goes here, the first thing that you're going to get is RBr. Plus, what will happen? This is going to go out in the form of water. So there are two hydrogens. So one of the hydrogen will go with this. So I'll write it somewhere here. H2O. Okay. Then what are you left with? You are left with Na here. And then you're left with H and you're left with SO4. So it gives you NaHSO4. Is it clear? This is what this reaction is. I said ROH is here. Then you're reacting with NaBr plus H2SO4. So what is going to happen? This is going to go here. So it becomes RBr. From here, this and from here, one water molecule goes. So H2O. And what are you going to be left with? Na and one hydrogen from here, SO4. NaHSO4. Is it clear? Moving on to the next reaction now. The third reaction is ROH when it reacts with PX3. Okay. What will you get? See, first of all, one thing very clear it should be is there are 3 halogen atoms. So for 3 halogen atoms to attach here, okay, let's see, it will become this way, right? This is going to become R and X. Obviously, this is going to attach here R and X. But you see how many halogens are attaching? 3. So obviously to balance it, I'm going to put this, and then what are you left with? You'll be left with H3PO3. Okay. How did you get that? We will see this step by step. I said ROH is there plus PX3. Got it? You know that whenever this is going to go and attach, what is this PX3 first of all? Trihalogen. Okay. So this will be phosphorus. Phosphorus trihalide, will name it. Phosphorus trihalide. I'll give you some 20 seconds to think, how are you going to get this? Take your copies, write down the steps. How will you get 3RX and H3PO3? Think of it. First of all, whenever we do this, what am I going to do is, see, this is 3 halogens. So obviously it is known to us that 3R will be required, isn't it? Otherwise, 3 halogen cannot go and attach to the same alkyl group having the carbon atoms. Got it? So first of all, 3 halogen will require 3 of these. Now you see, from here I can say 3ROH plus PX3 is going to give me what? This is going to go and combine here. So I get 3R and X. But what else are you left with here? 3 here means what? 3 oxygen. 3 oxygen. And this 3 means 3 hydrogen. And then if this goes, from here you are left with phosphorus. So how do I write it? I write it as H3PO3. Is it clear? I'm repeating it once again. Please have a look so that it will be very clear to you. I say I want to react an alcohol with phosphorus trihalide. So the very first thing is clear to us. For trihalides, That means 3 halogen atoms to be present. We will be needing 3 carbon atoms, and that is the reason to get those 3 carbon atoms, I will be needing 3 alkyl groups, which I have already taken here. So when I take 3 alkyl groups here, it doesn't mean just alkyl groups. It means what? How many R groups? 3. How many oxygen? 3. How many hydrogen? 3. Then I say that this X is going to go and attach here, and this is going to come out. So along with what else will be left? Along with the phosphorus here. Got it? So that is why we get here H3PO3 from here. 3 hydrogen, 3 oxygen, and on the counterpart, how many phosphorus? 1. Is it clear? Now let us move to the next reaction, that is with PCl5. So I say ROH plus PCl5 is going to give me RCl plus POCl3 plus HCl. Pay attention, everyone. I say this here, from here, only one chlorine goes and attaches here. You have to remember, in case of PCl5, one halogen will go and attach here. Got it? That means if one halogen goes and attaches here, it becomes RCl. Now you see what is left here. If I look here, this is left, oxygen is left, hydrogen is left, phosphorus is left, and how many chlorine will be left now? 4. So how will I react? I said P is there, PO is there, then you have Cl3 plus HCl. Let me make it more simple. You have ROH plus PCl5. See, step by step I'm going to do. First and foremost, out of the 4 chlorine, how many chlorine you have? Out of the 5 chlorine, one of the chlorine goes and attaches here. It becomes RCl. Then what? One of it has to go out in the form of gas, no? Something though. So H, and one of the chlorine from here will go away now. HCl plus. See, one of the chlorine got attached here. One of the chlorine went here. Total, how many chlorine you will be left? 5 minus 2 is 3. So 3 chlorine you will be left with. And what else apart from that? Phosphorus is there, oxygen is there, and chlorine. So POCl3. Is it clear? Now, the next and the most important, that is from ROH, how are you going to convert this? RCl plus SO2 plus HCl. This is the most important one, okay? Now here I take pyridine and SOCl2. Okay? Now this, here also what am I trying to do? I'm trying to convert alcohol into haloalkane. See, this is the most important reaction, so pay attention. What is this SOCl2? This SOCl2 is your thionyl chloride. How is this reaction done? See, the reaction is done like this. ROH plus SOCl2. The first thing, let us have a look here. How many chlorine do we have? 1, 2. One of the chlorine goes here. What does it become? RCl. Plus whatever can be taken out. What else is left here? H is left, and one of the chlorine is left from here. So I say HCl. And then what am I left with? SO and O here. So it is SO2. And always remember, this HCl and SO2 are escapable gases. Escapable gases, that means they will easily escape. If they easily escape, what are you going to be left with? You will be left with RCl, which is going to be called as pure haloalkane maybe. So can I not say that thionyl chloride is the best way of preparing haloalkanes from alcohols? Why is that so? Because whenever there is reaction of alcohol with thionyl chloride, it is going to result in the formation of two escapable gases. And those escapable gases will easily go out of the system, and then it is going to give us pure alkane. Is it clear? So again, once again, I want to just summarize with you all that from alcohols, how can we prepare haloalkanes? Let us have a quick revision so that we'll know. I say from alcohols, the first way that you can do is with the reaction of HCl and ZnCl2. This is known as Lucas reagent. What did we get? Let us recall. I got here RCl plus H2O. The mechanism I have shown you. And this is known as Groove's process. Let me recall one more thing. This ZnCl2 is going to act as a catalyst. And what will it do? It will weaken the carbon-oxygen bond so that it breaks and forms a carbocation. And this carbocation is an intermediate and takes part in the reactive reaction. Got it? Next that you have is this NaBr plus H2SO4 and reflux. You're going to get here RBr plus H2O, and let me go back to those reactions to show you in details. And what else will you get? And this is the reaction. Okay, so you're going to get RBr plus H2O and also NaHSO4. Okay. Then the next we have is PX3. If I react alcohols with phosphorus trihalides, what am I going to get? 3Rx plus H3PO3. I've done the mechanism already. PCl5, I'm going to get here RCl plus POCl3 plus HCl. And the last but the most important one is pyridine and SOCl2. What is this SOCl2? Thionyl chloride. RCl plus SO2, which is escapable gas, plus HCl. And. This process is known as Darzon's procedure. DARZEN apostrophe Darzon process. What is Darzon process? It is very simple. Whenever you react alcohol in the presence of pyridine and SOCl2, it is going to give you RCl and SO2 plus HCl. And remember, this SO2 and HCl are escapable gases, so they can easily escape, and then you will be left only and only with pure haloalkane. So, please add a note here. I want to say that, yes, let's make it this way. Darzon process is the best method to prepare haloalkane from alcohols, because in this process SO2 and HCl are produced, and these are escapable gases. So they escape easily. And pure haloalkane is obtained. Got it? Obtained. Is it clear? Now, some more methods are there. That is free radical halogenation. Free radical halogenation of alkanes. Then we have addition of hydrogen halides. hydrogen halides. Okay. Addition of hydrogen halides on alkenes. Then we have halide exchange, and in halide exchange we are going to study the most important reaction. What are those most important reactions? These are named reactions, so we have to study them properly. One is a Schwarz reaction. Then you have the Finkelstein reaction, and you have the Hunsticker reaction. Okay. Hunstdiecker reaction. So these preparation methods also we have to study in details. But for today's class, we shall keep the discussion till here. And whenever we meet in the next class, we are going to discuss the other methods of preparation of haloalkanes. And what are the other methods of preparation? Free radical halogenation of alkanes, addition of hydrogen halides on alkanes, and halide exchange. In halide exchange, we are going to study the three most important named reaction, that is the Schwarz reaction and the Finkelstein reaction and the Hunsticker reaction. Is it clear? Now, all of you should study sincerely, go through whatever we have discussed in today's class, and in case if you have any doubts, you can always drop a word in the comment section so that I can help you to solve your doubts. But study regularly, study sincerely. Is it clear to everyone? And in case of any doubts, as I said, always feel free to mention in the comment section so that I can solve your doubts. Do not wait. Always, whenever you have doubts, you should quickly respond and seek for clarification. Is it clear to everyone? So, thank you everyone for watching this session. I hope you all have enjoyed this session. Study hard and concentrate well, and stay tuned for the next lecture. Thank you everyone. Have a good day ahead.